Hello, my dear students, and the rest of the learners. Welcome to part 22 of a 29-part series of tutorials in Fundamentals of Structured Programming using C. In this presentation, we are going to look at what we call the multidimensional arrays. My name is Memedi M, or you can simply call me Emily Swap. What are dimensional arrays, or what are multidimensional arrays? Multidimensional arrays are the arrays that are used to represent scenarios with many dimensions and data organized in several rows and columns. They range from two-dimensional arrays, three-dimensional arrays, four-dimensional arrays, and above. They can be two-dimensional, three-dimensional, etc. For example, if two students sit for 10 exams each, and you want to store the scores attained by both as an array, this will be a two-dimensional array, whereby one dimensional would represent the number of students, while the other dimension will represent the scores attained by each student. But kindly note that you don't write the names of the students. You use numbers. If you have two students, for example, and one student is called Julius, and the other one is called Otieno, then you serialize them. For example, Julius can be number 1, while Otieno is 2. And therefore, when we speak about one dimension representing the number of students, it simply means that you write those students as 1, 2, while the other dimension would represent the 10 scores attained by each. And therefore, you don't write the name of students if you are going to enter the scores they have attained. Remember, as we said in the previous presentation, that is presentation number 21, which is already posted in the MediSwap IC YouTube channel, we said that an array are a group of memory locations which contain values of the same type, and all of them are named with the same name. And therefore, you don't mix the data types. If it is numbers, it's numbers. If it is text, it's text. Because if you mix data types, or you want to store data types on different data types in the same memory locations or memory location with the same name, then that is no longer called an array, but it is another data structure that we are going to learn in the series or in the subsequent series in this presentation. So in this case, just as I've said, each row will represent a single student with a number like 1 or 2, or each column will represent the scores attained by each of the 2 students, but not in a single exam. Now, it's not a must that it be a single exam, but you must be able to identify what the scores entail. This array will therefore be of the order 2 by 10. That is, 2 rows with each row representing or containing scores for a single student, and 10 columns with each column representing a score that has been attained by each student, or scores that have been attained by each of the 2 students. Now, this data can therefore be represented as follows. The array name is performance. So you can see the way I have numbered them. In this table, it is very clear that the columns represent the exam number, like exam 1. So exam 1 has been sat by 2 students. That is student number 1, who I'm identifying with the row index, and the student number 2, who I'm identifying with the row index, whereby student number 1 is index 0, and student number 2 is index 1. Now, if you watch carefully, because this is what is more important for you to understand, my dear students and the rest of the learners, is that the students are listed here. So this is the list of the students. But of more importance is that the scores attained by each of the students are listed as follows. And therefore, student number 1 has done 10 exams with the first score in the first exam being 45. The second one is 90. The third one is 20. The fourth one is 53. The fifth one is 100. The sixth one is 15. The seventh one is 78. The eighth one is 34. The ninth one is 11. And the 10th one is 60. And therefore, this row contains scores attained by student number 1. But as you can see, these are 10 exams. And therefore, the exams are listed from number 1, number 2, all the way to number 10. And therefore, you can see that you can easily say that number 1 represents column 1. Number 2 is column 2. And this column 1 is not just for a single student, but it is scores attained by the 2 students in the same exam. So because of the fact that in a 2-dimensional array or in an array, you only make use of a single data type, then that is a clear indicator that you will not include student names. So you just identify them, like student 1, that is row 1, a student 2, that is row 2. And then you list the exams or the scores attained by the students. So like, for example, this can be 10 exams with different names, but instead of using the names, you identify them with the numbers. So back in your mind, you know which unit is number 1, which exam is number 2, which exam is number 3, which exam is number 4. Because when it comes to entering these values in the computer while using a 2-dimensional array, you will not enter the names of the exams, neither will you enter the names of the students. So you have to know that 1 is for which student, and 2 is for which student. And therefore, the most important thing for you to note is that each of the score, because we have this score and this exam, both of them being scores attained by the 2 students in each or in a single exam. Then you go to the second exam and the students have scored as 90 and 54. Then the exam is 20 and 21. And therefore, my dear students and the rest of the learners, once you understand what is in which row and what is in which column, then it becomes easy. And therefore, we are saying that this array called the performance is a 2-dimensional array because on 1 dimension, we have the students. And then on the other dimension, we have the scores attained by each of the students. So we have in 1 dimension, or in one dimension contains the students, while on the other dimension, we have the scores attained. So this is a 2-dimensional array. It's composed of rows and columns. So our columns contain the scores. Our rows contain the students. So on the first row, which I'm calling row index 0, we have student 1 and his or her 10 scores. On the second row, which I'm calling row index 1, we have the second student and the scores, the 10 scores attained. When it comes to storing these values in memory, It is important for you to note, as we said in the previous presentations in this series, that the compiler or the processor identifies the elements of a memory location or elements in an array using index. And the first element is identified as having index 0, and the second one, index 1. So the rows, the first row is index 0, and the second row is index 1. When it comes to columns, the columns are also identified using index, where column 1 is index 0, column 2 is index 1, and the last column is index 9. So rows span from index 0 to index 1, while columns span from index 0 to index number 9. So the 10th element or the 10th column is identified by use of index 9, while the first column is identified by use of index 0. And therefore, with that knowledge, then we can proceed and see how the array behaves. This array is therefore called performance, and it is composed of two subscripts, which are subscript 2, identifying the number of rows or number of students, and subscript 10, identifying the number of columns, which of course in this case is the number of elements or the number of scores. So 2 will represent the student numbers. So these are 2 students, and each of them has scored or has values or has scores for 10 subjects or 10 scores. So this simply means 2 students with each having 10 scores each. So 2 is for the first dimension, that's the number of rows, and 10 is for second dimension, which is for the number of columns. And therefore, my dear students and the rest of the learners, it is important for you to note how we organize the subscripts. If it's a 2-dimensional array, you begin with the rows and then the columns. That's why you can see as emphasis that subscript 2 is for the first dimension, which represents 2 students. For the second dimension, subscript 10 represents the 10 exams done by each. Therefore, the number of rows and the columns of an array, or what we can also call matrix, or a 2-dimensional array defines its order, or the number of indices that an array declaration has determines the type of the array. The syntax for defining a 2-dimensional array in C is as follows. So if we want to tell the compiler to reserve for us memory locations that are going to accommodate a 2-dimensional array, then we can do it as follows. We have the data type followed by the array name. Remember, the array name is the one which helps you identify what the values that are going to be stored in that memory location represent. Then we have the size of row, how many number of rows, and then the size of column, that is how many number of columns. For example, in our case, the name of our array is performance, just as you have seen. The scores we are going to store in our memory locations are for scores attained by 2 students in 10 exams or 10 scores. And for that reason, those scores are whole numbers, as we have seen, 10, 50, 78, etc. And therefore, the type of data that I'm going to store is of type integer. So for us to tell the compiler to reserve for us a memory location, which is, of course, going to hold values of 2 dimensions or 2D, that is 2-dimensional array, 2 rows and 10 columns, Then what we are going to do is we are going to write this statement at the declaration section of our program as follows. So this statement simply tells the compiler, pick some memory locations, set them aside to accommodate an array of the following size, that is 2 rows by 10 columns, and the type of data to be held in those memory locations, which we are naming as performance, is of type integer or whole numbers. To refer to a specific element in the array, you specify the name of the array followed by the position number, that is index or subscript, of that particular element in the array, while stating or while starting with the subscript of the row, then the column if the element is stored in a multidimensional array. My dear students and the rest of the learners, before you do or you go through this part of the series, I would advise that you go through the introduction to arrays and one-dimensional array in part 21 of this series so that you can gain understanding of how we move from one-dimensional array to two-dimensional array so that you can have a better understanding of what we call the subscripts or the index. For example, to refer to element 100 in the array called performance, you can write it as follows. Is performance, row 0, column 4. Now, what does this mean? This simply means that value 100 is having or is placed in the array or in memory location at index subscript 0, which of course that means it is the first element, but simply, if I have to phrase it easily, this simply means that 100 is on the first row, Remember, the first subscript represents the rows. So it's on the first row in the array, that is first position on the row, on the first row, and for the index. Now, for the column, for the index, for the column, which is column number 5. Note, I repeat, 100, for you to refer to value 100, you move to the row first and then the column first. But what we are using are the index. Now, remember that the index for elements in the array begins with 0. So the first value or the first position is identified with subscript 0. So first row is subscript 0. And then subscript 4 will represent the fifth column because the columns are numbered from 0 to the end. Let's see. Let's go to our array. Here is our array. You can see that for us to refer to this value here, value 100 in the array, we have to tell the compiler or the processor that 100 is found in row 0, which is correct, but where? But on the fifth column. This is very clear here. Column 1 is index 0, or column 1 is index 0, column 2 is 1, 2, 3, 4. Now you can see that our value 100 is in column 5, which is identified by use of subscript 4. So this is the row. And then which column? Column number 5, which of course is subscript number or index number 4. Note this, 100 is in the 50th position, but 50th position is identified with index 4. So when we want to refer to 100, first of all, we have to tell the compiler that go to the memory location by the name performance, but then where in that memory location? Go to row index 0. Remember, index 0 is all the way. Go to row index 0. Then which column? Which index for the column? Column number 5. Column number 5, which is index number 4. So if you are to refer to these elements, all of them, for the first row, if you are to refer to all the elements in the first row, from column number to the last one, it will be as follows. This one would be index 0, that is row 0, column 0, row 0, column 0. Next is, I repeat, that is row 0, column 0. That is which value? 45. Then row 0, index 0, 1. Index 0, 1. That is 90. All the way to index row 0, index 9, which would refer to value 60. So 0, 0, 45, 0, 1, 90, 0, 2, 20, 0, 3, 53, 0, 4, 100, 0, 5, 15, 0, 6, 78, 0, 7, 34, 0, 8, 11, 0, 9, 60. If you go to row 2, it will be 55 years, 1, 0, 55, 1, 1, 54, 1, 2, 21, 1, 3, 65, 1, 4, 73, 1, 5, 65, 1, 6, 33, 1, 7, 57, 1, 8, 18, 1, 9, 24. So when you look carefully, my dear students and the rest of the learners, value 24, which is the last one in this array, will be represented or identified as performance 0, 9. That will be the highest index. 1, 9. So it will be performance 1, 9. Performance index 1, 9. So subscript 1, subscript 9. So that one can even be written as follows. Performance 1, and then 9. That will be the highest subscript. Meaning you are telling the processor Go to the memory location called performance. Index number 1, that means row 2, but column number 9, that means that's index number 9, column index number 9, which means column 10. So go to the memory location whose index is for the row 1, for the column 9, meaning go to column number 2 in, I repeat, not column. Go to row number 2, go to row number 2, but column number 10. My dear students and the rest of the learners, as we said in previous presentation, number 21, we said that if the column, the physical column is 2, its index is 2 minus 1. So that is index number 1. If the column, the physical column is column number 10, in memory it's identified as 10 minus 1, that is index number 9. So that's the difference. The physical, for you to get the physical row for a value in memory, the physical row, you just get that index that you have been given, you add 1. For example, if index is, the first index is 1, you add 1 to it to get the physical position, which is 2. For the second dimension, if you are given index number 9, then it means that in physical memory, you can trace that value by saying that index plus 1, which gives 10. So this will mean this is physical column number, this is physical row number 2, physical column number 10. But in terms of index, it is index number 1, then index number 9. That's how we interpret the rows and the columns, my dear students and the rest of the learners. And that's why if you want to refer to 100, we have seen, you write it as performance, then first subscript is index 0, second subscript is index 4, meaning that in the physical memory, this value 100, is found in the column number 1, first column, not first column, but first row. I repeat, this simply means that you are telling the compiler, you are telling the processor that 100 is found in the first index for the first row. That means row number 1, but column number 5, that is index 4. I repeat, when you write this statement in a program, it simply means that the value you are referring to is a value in the array called performance whose row index is 0 and column index is 4, meaning that this value 100 is found in the memory location called the performance in the first row but 5th column. Element 55 is accessed using the statement performance 1, 0, meaning that in the memory location called the performance, 55 is found in the second row, but column number 1. Second row, but column number 1. Why? Because index 1 represents column number 2, that is row number 2. Index 1 represents row number 2, while index 0 for the columns represents column number 1. I repeat, for us to refer to value 55 in memory, we write it as performance. That means that's the name of the memory or the name of the array. And then first subscript indicates that this is a row, but which row? Row number 2 because its index is index 1. So you go to row number 2, but which column? So the second subscript represents the index for the column number. So index 0 represents column 1. So 55 is found in row number 2, but column 1. And element 24 is accessible as performance, index number 1 for the row, then index number 9 for the column, meaning that 24 is found in the second row, but 10th column. Let's see if that is true. Remember, we are referring to 55 and the 24. Let's see. 55 and the 24. 55 and 24. Where's 55? This is 55, and then this is 24. So in this array, you can see that 55 is found in the second row, whose index is 1, and first column, whose index is 0. So 55 is identified as performance, index subscript 1, then index subscript 0. The other one is 100. As you can see, 100, or the second one is 24. So you can see that 24 here is in the second row. Remember, this is first row, this is second row. So 24 is found in index number 1 for the row, meaning column number 2. Not the column, but row number 2. I repeat, so as to avoid any confusion, we are referring to value 24. 24, as you can see, is found in the row whose index is 1. Row index number 1 is row number 2 because index 0 is row number 1. Index 1 is row number 2. So 24 is found in row number 2 whose index is 1. But in which column? In column number 10. And the column number 10 is identified as index 9. So you can see that for you to tell the processor to refer to element 24 in the array, you tell it is that the name of the memory location of the array is performance. So go to the memory location called performance, row whose index is 1 and whose index for the column is 9. So that's how you refer to the various elements in the array. My dear students and the rest of the learners, once you have known how to identify various elements, you can then be able to perform any other operation with any element of the array, just as you do with any other variable, as long as you refer to that element in the array appropriately. The entire array cannot be manipulated using a single statement, and therefore, array elements are usually manipulated one at a time inside a loop that iterates many times. The most commonly used control structure is for loop. The number of dimensions that an array has determines how many nested loops will be required to manipulate all the elements of the array, because each for loop will refer to either a row or a column. So if it's a two-dimensional array, which has rows and columns, it means that we're going to have one for loop handling the row, while the other for loop will be manipulating the elements in the columns. The following is therefore a source code for a program that initializes a two-dimensional array that we have looked at on the performance with the following elements, then computes and displays their total and displays the array elements as organized in the array. So if we want to store these values that you have looked at in the memory location or as an array, then we are going to have the name of our array being called performance, and then we declare the number of dimensions. So this will be two dimensions, one dimension for the rows and the other dimension for the columns. And remember, we have seen that to identify, or the processor identifies the first row using index 0, and the last column, or the first column using index 0. So if you are going to store or to create or request a processor create a memory location that is going to hold values in 2 rows and 10 columns, we are going to give the subscripts. We are going to give our subscripts of the numbers as 2, 10. Performance, first subscript 2, and the other subscript 10, meaning 2 rows and 10 columns. Let's see that practically in the program so that we can be able to avoid any confusion between the use of rows and the columns, between referring to an element and declaring of an array. So our comment is a two-dimensional array initialization and manipulating array elements. This means that our program that we're going to create or code is going to initialize or store all the elements in the array, which we are then going to manipulate and see what happens. We have preprocessor directive there. We have our main function there. And then we declare the following variables: sum, column index, row index, and they are going to hold the value of type integer. The next statement is a statement which is declaring our array and also initializing that array with all the elements. So this is how you interpret this statement. This statement tells the processor to create or set the memory location assigned called the performance, which is going to hold values in 2 rows and 10 columns. Values in 2 rows and 10 columns. And the name of this memory location is going to be called performance, and the type of values that are going to be occupied or to be held in those memory locations will be of type integer. And then we are going ahead and assigning the specific values to the array. And those values will be stored by the processor in the order of listing, whereby the values to occupy the spaces for the first row will be 45, 90, 20, 53, 100, 15, 78, 34, 11, 60. For the second row will be initialized as follows: 55, 54, 21, 65, 73, 65, 33, 57, 18, and 24. Now, what you need to note, my dear students and the rest of the learners, is how we write we do our initialization. You can see that we have the outside brace here. We have this brace, and we have this other brace here that marks the boundaries where our first element will appear, or our first row and our last column there. But then, to be able to inform the processor what belongs to the first row and what belongs to the second row, we also have this brace that marks the beginning of the first row or the beginning of the first row and the end of the first row. And then we have a comma here. And then we have this brace marking the beginning of the second row and this brace marking the end of the second row. So that's what is more important. And then both rows are enclosed inside the outer, the inner and the outer braces and a semicolon. That is very important to note. Then from there, the next part of our code is to compute the sum of the elements as follows. First, we assign or initialize the memory location called sum with 0. That is for the purposes of clearing any type of values that might be there, because ordinarily memories are not empty. So to ensure that we have accurate information or accurate data in our memory, that is called sum. That's why we're initializing it with value 0. So we are assigning 0 in the memory location called sum. And then, because our array contains 2 dimensions, the first dimension being for the rows and the second dimension being for the columns, we begin with the for loop for the row. So we have 4, then we initializing our row index with 0. Next is to check whether the value in our row index, in the memory location called row index, is less than 2. Remember that our rows are 2. So the first row is index 0 and the second row is index 1. That's why we are having a condition that check whether the current content of the row index is less than 2. If that is correct, do the following. Go to the column. And which column is it? Initialize column index with 0. Then check whether the value of column index is less than 10. So if the row index is less than 2, meaning that we are accessing the right row, and once the right row, the correct row has been identified, go to the column, initialize the first column with 0, that is column index 0, the column index memory location with 0, and check whether the value of the column index is less than 10. If the row index is less than 2 and the column index is less than 10, then do the following. Do the following. Pick the content in the memory location called the performance, whose row index is 0 and column index is 0. So performance index row 0 and index for the column 0, that value is 45. So the processor will go to the memory location called the performance, which we have already created and initialized, and pick the element whose value is index 0, that is row 0, index row 0, and column index 0. That is 45. And that value, the current content of memory location called sum. And the current element or the current value of the memory location called the sum is 0. So this means that this statement will pick, the processor will pick value 45 and to 0 and assign the result into the memory location called the sum. So 0, that is 45 plus 0, will be 45. And therefore 45 will be stored in the memory location called sum. Once that is done, the processor will be taken to this next part here. Once it encounters this brace, the control will move to the last statement here. which tells the processor to increment the value of column index. Initially, our column index is having value 0. So when we increment it with 1, it will become 1. So column index content there will be 1. So then the compiler or the processor will come here. Check if 1, the value in the memory location column index is less than 10. And that is true. 1 is less than 10. If that is found to be correct, then the processor will enter into the loop here and perform this statement. So the row index is still 0, but now column has become 1. So this tells the processor to go to the memory location called the performance, index, row index 0, column index 1. That will be value 90. This is row 0. This is row 1. Then this is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what this will tell the processor is go to the memory location called the performance, which you want to set assigned. Row index 0, we are there, and the column index 1. You can see that. Row index 0, column index 1. That will be 90. So pick 90 and it to the current content of memory location called sum. And we have seen that the current position or current content of our memory location called sum is 45. So it will be 90 plus 45, which will give 135. And then from there, once this places any countant, the control will be taken back there or up here again, which tells the processor to pick the current content of memory location called column index and increment it with 1. And of course, our current column index is 1. The value which is inside there is 1. So 1 plus 1 will become 2. Then the control will be taken to the condition. Check if the current content of column index, which is 2, is less than 10. That is correct. If that is true, then go and pick the value in the memory location called performance, index 0, but now column 2. So the element in the memory location called performance, index 0, 2, as you can see, is 20. So that will continue. The cycle will continue. This activity will be performed. The cycle will continue until when the column index, the value in the column index will be 10. The total will be 10, or final value will be 10. Because once this value reaches 10, and the compiler checks this condition and finds out that the value in the column index is 10, you can see the condition will be is 10. Less than 10, no. And therefore, this loop or this part will be skipped. That part will be skipped. And then once that part is skipped, the control will come to this brace here. The control will encounter this brace. And once it encounters this brace, it will move now. The control will be taken up here, where we have the statement which is telling the processor to increment the content of row index with 1. Initially, row index had the value 0. So if we increment the 0 with 1, it becomes 1. And therefore, the value of row index will be 1. So the condition will be checked. Is 1 less than 2? Yes. Then it will enter in the loop again, and then counter this for loop for the column. Initialize column again. Initialize column. Remember that already we had incremented our value of the column here, all the way to 10 here. Now, when we come again to this part here, where our row index is 1, then it means when the row index is 1, our column will be index 0. So the value we are going to be referring to now is this one. In row 1, row index 1, but column 0. Then check, is 0 less than 10? Yes. So it will perform this activity, but then what will be here now is 1. So it will check the current content of row index 1, column 0. Pick that value, which is 55, and to what is in currently in the memory location called the sum. And what will be contained there is the last value that we got after computing of all the elements for the first row. That is for row index 0. So the value which is going to be added here, that's 55, will be added to already an existing total for the first row, because now you'll be adding value for the second row. So once that is done, once that value is returned to, the process will continue and increment column index with 1, which will be 1, and then check, is 1 less than 10? Yes. So the same operation will now be repeated until all these elements are added. Remember, the outer loop for row index, the purpose for this was to control the rows. So after adding all the values in the first row from column index 0 to column index 9, we have now incremented it with 1, and therefore the row index is currently reading as 1. So that means that our control is already in the row 2, whose index is 1. And then this for loop here, this for loop will carry out the execution of addition of all the elements, referring to each of the elements in the second row, all of them from column, first column to the last column, column 10, that is index 0 to index number 9. And then once all that is done, this is encountered again, the processor will increment the value of row index again. That means now it will be 1 plus 1, and the value of row index will be 2. So the condition will be checked. Is 2 less than 2? No. So this loop will be exited, and the processor will move now to the next line. And the next line in our code is this statement. So this statement is going to be displayed on the screen. The following are the elements as organized in the array. So this text will be printed on the screen, and then followed by this text, performance. Now, the purpose of this statement, my dear students and the rest of the learners, is to help you to be able to know that the name of our array is performance, and it's a two-dimensional array with 2 rows and 10 columns. That's the purpose. So this text will be displayed on the screen. Performance subscript 2 subscript 10 equals 2. And then we are now going to write out our elements using the same for loops we have used. But this time around, the purpose of these for loops is to control the reading of elements in the array and writing them out. So the same logic will apply. So first of all, once This statement is an accountant. The logic will be the same as I've explained, where the row index has been initialized to 0, and we check the control. Check the condition if the value of row index is less than 2. If that is true, do the following: display this statement on the screen, and then move to this control for the inner loop. That is the column loop, the loop for controlling elements in the loop. That is the loop for controlling elements for the columns. So where index of the row is 0, that means row 1, do the following. If initialize column index with 0, check if the value of column index is less than 10, which is true, 0 is less than 10. When that is true, go to the memo location called the performance, whose row index is 0 and the column index is 0. Leave that value which is there and write it out on the screen, 10 to 5 spaces. And then once that is done, once the last brace here is an accountant, increment the value of column index with 1. Check if the new value of column index is less than 10. If that is true, then read the element which is in row in the memory location count performance at now column index 1. So that will continue as the elements continue being written, and the column index will be given to 2, to 3, to 4, to 5, up to column index 9. Once that is an accountant, or once that is done, and the value of column index is incremented from 9 to 10, meaning that 10 is not less than 10, then the processor will move on, display this statement, this brace, and then display this other statement on the screen, which talks about creating spaces. And once this brace is an accountant, the control will be taken up here. The control will be taken up there. And the value of row index will not be incremented with 1, which will become 0 plus 1, and this will be 1. And once the value of row index is 1, the condition will be checked. Is 1 less than 2? Yes. So the control will be taken now again to this statement inside the loop, where this brace will be displayed. And then the process will enter now into the loop, initialize column index to 0, check if the value of column index is less than 10, which is true, and perform these operations again. So this process will continue again, will continue until the value of column index is more than 9. Because once that element is referred to, element in index, row index 1, a column index 9 has been defined to, once that value has been picked, it means that the processor will now move on and finish this activity here and increment again the outer value for the row. So the control will be taken up there. The control will be taken up here. The value of row index will be incremented with 1. So 1 plus 1 will be 2. And then the condition will be checked. Is 2 less than 2? No. Then this loop will be exited. The whole of it now will exit because the writing out of values will have been completed. And therefore, the next statement which will be written is this one here. So the message whose total is will be displayed on the screen, and then the processor will go to the memory location called the sum, pick the value which is there, and write it out on the screen. So the statement will read, for example, as whose total is. If the sum is 95, it will read as whose total is 95. That's just an example. And then the control will be taken to this statement, which is telling the processor to take the control back to operating system because execution of this program is complete and the program will end. So my dear students and the rest of the learners, having gained that understanding, the following is also a source code that prompts the user to enter array elements into a two-dimensional array called performance of order 2 by 10. It then computes the sum of the elements and then displays the array elements as they appear in the array, inclusive of their total. Simply, what I want to do now is, after you have learned this program and how it works, which of course is initializing the elements. These elements have been initialized in the program, and therefore the user has no freedom to enter his or her values into the array. Now, ordinarily in real life, this cannot be used because this program is purely for identification or for helping you learn how an array works, two-dimensional array, and how the processing is done. Now, having learned that and having known how an array works, ordinarily then, the user is supposed to have freedom to determine the values of this array or an array. So you can enter very many elements into a program, and then you allow it now to do the computations and perform other activities on the data. And therefore, this other example is an example now, which is similar to the one we have discussed, but this one gives you the freedom to be able to enter the values into the array yourself. So the only difference between this program and the other one that we have discussed is, instead of initializing our array with elements, we just know the compiler set memory location assigned called the performance, which is going to hold the values of type array, whereby it is being requested to have a memory location to hold the value of type integer for 2 rows and 10 columns. Now here, we don't initialize it. We just leave it open. We just set the memory locations assigned to hold the array, which is a two-dimensional array. And then we are now going to enter various values into it. The next statement is similar to the one we have discussed, where we are declaring memory locations called row index, column index, and the sum. And then the next thing now we are going to do, which is not similar or the same as the one which we have dealt with, is now we are introducing a new or a portion of our program that is going to read or accept values from the user and assign them in the array, which is different from what we have already discussed. So the only difference here, this second program is allowing the user to determine the content of the array. In the one we have discussed, we have initialized the array with specific elements. But in this program, this is a program which is flexible. It will prompt the user to enter the elements that he or she wants to be in the array, and then the array or the program will perform the various operations, just as we have seen in the previous program. So we are going to display this statement on the screen, or this statement tells the processor to display the following statement on the screen. Entering elements into a two-dimensional array performance, array called performance, whose number of rows are 2 and number of columns are 10. So this text will be displayed on the screen. Then followed by the name of the text, array element index. From there, there is a for loop that will allow us to enter various elements. I will not really explain too much about how this loop will work because it's the same as the one which we have discussed, but it's good for me to just highlight that we are initializing the value of the row index or the memory location control index with 0. Then we check if the current content of memory location control index is less than 2. If that is true, we do the following. We go to the loop for the column. We move to the column. We initialize the value of column index with 0. Then we check if that value is less than 10. If that is true, we do the following. So we perform this activity here, which of course is meant to display the row number and the column number, the row index and the column index, to allow the user enter the value. And then here, The user is keying in a value. That value will be read, and it will be stored in the memory location called performance, whose subscript is, the first subscript will be 0, 0. So once that value is entered, it will be stored in the memory location called performance at index 0, 0. That is subscript 0 for row index and subscript 0 for column index. Once that value is read and stored, and this place is an accountant, the process will increment the value of column index, then check if that value is less than 10. If that is true, this statement will be displayed, and the only part which will change is the column index, because we are still in row index 0. So the column index will become 1, and then this statement is then the processor pick the value which will be entered by the user and store it the memory location called performance in row index 0, column 1. So that will continue, the loop will continue. The second element to be read will be row 0, column 2. The other one is 0, 3. The other one is 0, 4. The other one is 0, 5. The other one is 0, 6. The other one is 0, 7. The other one is 0, 8. The other one is 0, 9. And once 9 is reached and it is incremented with 1, it means that column index will become 10. So you check, is 10 less than 10? No. So once this is an accountant, the control will be taken up to the last statement here, which is row index, incrementing row index. So row index will be incremented from 0 to 1. So once row index is 1, this activity will continue again from here. So the elements that will be read will be from 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9. And once that is done, and the value of column index is more than 9, the condition will be checked. Is 10 less than 10? No. So this loop will be exited, and then the processor will increment the value of row index with 1. So 1 plus 1 will be 2. It will then check, is 2 less than 2? No. So that means that this loop will be exited completely. No activity will be carried out, and the control will be taken to the next line, which is computing the sum for the elements. And this, the path for computing sum, will continue the same way I've explained, where now all the elements will be added, beginning the one which is in row index 0, 0, column row index 0, column index 0, all the way to the element which is in row index 1, column index 9. And once that is done, the total, all the elements in the array will have been computed. From there, we move on to displaying the elements of the array, and this statement will be displayed on the screen. The following are the elements as organized in the array. So this statement will be displayed as it is, and then using the for loop, we are going to write out the elements of the array, beginning with the index subscript 0 all the way. So this part is similar to the other part that we have discussed in the other program, which was initializing the array with elements within the declaration. So the control will be taken back to the operating system once this statement is an accountant, and the program will end. My dear students and the rest of the learners, let us now code this program that we have discussed using Falcon IDE so that we can see how it will behave when executed. Therefore, my dear students and the rest of the learners, we are going to code these two programs. Let's code these two programs, this program, so that we see whether it is going to give out this array as it is, and also do the computation. And then we code this other program, which is going to give us an opportunity to enter our values into the array. So let's proceed. We are going to start Falcon in our computer. So let's search for Falcon. Here it is. So we click on Falcon. Once it loads, we create our project. And our project, we are going to call this project 2D, two-dimensional array initialization. 2D initialization. That's the name we are going to give, and this the compiler type is C, so we click on finish. Then we create a file for our project. We'll name it, and our naming will be two-dimensional array initialization. That's our program. So we open it, and then we can key in our code here. And because we have already coded our program, or we have typed our program, I'll just paste it here, and then we run it to see how it will behave. So this is our program. This is the program that we have already discussed, where we are initializing our array elements, as you can see there. Remember, it's a good programming practice to indent your program nicely. So that's our program. And I want to format it so that it looks more presentable and readable. So we have our precursor directive there. We have initialized our array called performance here. Then we are computing the total of our array here. And then this part is for displaying the values of our array on the screen. That's where we are. That's what that part will do. So we are going to write out all the elements in the array, or from the array, using this part of our program. And then this statement is going to display the sum of the array. Now that we have already discussed this program, we can just save our program, that is save the project, and save the program. We are going to learn how to do the saving. So let's compile this program. Click on run, then compile. You can see that it has no errors. There's no errors. So let us execute it. Let us run it and see. There we go. My dear students and the rest of the learners, you can see that for this program, the user is not performing any operation during execution, because just as I've said, having explained this array, its main purpose or function is to help you to be able to see or know or understand how a two-dimensional array works. You can see I have output this array, the elements of my array, just as they appear in my initialization part of the screen. You can see in the declaration, I have int performance, 2 rows and 10 columns, and you can see the values are here. And my dear students and the rest of the learners, you can see that I have displayed those values from this section of the code, or using this part of the code for returning the values. So this program is accessing the values in my array in the memory location called performance and writing them out formatted exactly as my initialization looks like. You can see In column 1, we have 45, 55. Column 2 is 90, 54. Column 3 is 20, 24. Column 4 is 53, 65. Column 5 is 173. Column 6 is 15, 65. Column 7 is 78, 33. Column 8 is 34, 57. Column 9 is 11, 18. And column 10 is 60, 24. That means that these elements are spanning from index 0, 0 to index 1, 9. And the total is there, whose total is. So you can see that the last statement in my program has done, or the process has done good work, because it is being displayed on the screen, the text whose total is, then the processor has picked the total or the value in the memory location called the sum and written out. And the content in a memory location called the sum is 971. And therefore, we can press a key to continue, and that's how this program will work. Let us now save this program and close all and come out of that program so that we can proceed and decode this other program now, which will help us or enable us to be able to enter our personal values. The array remains the same, everything remains the same. The only difference is that now we are going to key in our elements ourselves. And we are going to discuss this program. So you can copy this program, write it in your exercise books, or copy it in one processor, or just type it directly on our Falcon IDE. And then we run it and see whether it will behave as I have already explained. So again, we load our Falcon IDE. So let's load our Falcon IDE. And remember to do the same in your computer. Do the same. Then we create a new project. This is an empty project. The name of our project now, it will be, of course, 2D. It is array, but then in this case, I'm not going to call it array initialization directly. I'll call it 2D array user initialization. User initialization, because it is the user who will assign values into the memory location. So user entry initialization. So I'm calling it just user initialization. The compiler type is C. So we click on the finish. Then we create a file under it. That's a C file. We rename it. We name it as 2D array user initialization. That way. And then, because if only we have already discussed our program, we are just going to paste it here because I've already coded my program. And if you have not, you can just type it directly on this editor. So let me just paste my program here. This is the program that we have already discussed. As you can see, we have a preprocessing directive here. We have declaration of variables here. You can see this is my array declaration. It's a two-dimensional array, just as I've explained. And then this is the part of our program, which is going to do the reading of the values from the user. I just want to indent it nicely. That way. So you can see I have row index here, and it will terminate when the value of row index is going to be 2. That means once row index is not less than 2, that's when the outer loop will terminate. And also the inner loop will terminate when the value of column index is no longer less than 10. So we are going to explain that. So the elements will be read from the keyboard and be stored in the specific positions in the array called performance. Then this section is doing the computation of the values of the totals of the array. So the work of this section is purely to do the addition of the elements in the array. And my dear students and the rest of the learners, kind of note, if you are still wondering how the for loop is working, the nested for loops, because my program, this program or my programs in this presentation are making use of nested for loop, I would advise that you go through the series of my presentations in which we talked about for loop and more so the nested loops, so that you can be able to understand how the for loop, inner loop, outer loop works, or what we call the nested control structures. Then this part is doing the writing out of the values from the array, including computing the sum or the total. In fact, it's not computing, but simply displaying the values on the screen. That's what this part is doing. This section of the program is simply meant to write or read the values from the memory location or from the array and write them out on the screen and formatted appropriately. And once that is done, the control will be taken back to the operating system and the program will end. So there's a program that we are going to discuss. And therefore, let's save it. So we click on file, but then we save all so that we also save the project. And all is selected the files. The name remains the same. The location remains the same. From there, we are going to compile our program. So let's compile our program. You can see that our program has no errors. Compilation success. As you can read at the bottom of our IDE, that is on the Falcon IDE status bar. Let's run this program so that we see how it will behave. So my dear students and the rest of the learners, you can see that the difference between this program and the other one which I've demonstrated is that this program is giving you the opportunity to enter the values. So if we type, for example, 23, once we press enter, you can see the row index is 0, but the column is the one which is, the column index is being incremented. Column row 0, column 0, row 0, index 0, column index 1. So 0, 1. Next is 0, 2. That means we are already in the inner loop, and what we are incrementing now is the column index. So we are working with the column index. You can see it has gone from 0 to 9. So we expect, because that is the highest value in the first row is row index subscript 0, 9. So we expect now that the outer loop for the row will change. So we expect us to move to row index 1. Let's see, you can see. We are now entering values. We are already done with the first inner loop, and now we have incremented the process, incremented the value for the row, and now we are moved from index 0 to index 1. This means second row. And then now we read all the values from column, first column to the 10th column, but that stands from index 0 to index 9. So we expect the column to be changing here. So I can enter the values. You can see that what is now changing are the subscripts for the column, as you can see. So once I type that value, remember The highest value is in index subscript 1, 9. That means row 2, column 10. So once I press enter here, I expect that the browser will do the computation, and then all these values will be displayed on the screen together with their total. Let's see. Let's see. So the following are the elements as organized in the array. You can see there. That is true. The elements, as you can see, the elements you have entered from index subscript 00 span from 23 all the way to index subscript 19, which is 43. And you can see that that is the value at the end here. So the first value which we entered is this one, index subscript 00. And then the last value we have entered 43 is index 19. So that's a very clear indicator. It's a very good program that shows you how our array will work. Remember, you can perform any operation on the elements, like the one which we are working on for computation. You can see we have displayed the values from the array. We have also, the program has also computed the sum, and it has displayed the total on the screen. The statement is, whose total is 1172. So the good thing with this program, let me press any key to continue. The advantage with this program is that you can enter any values in this array, and their sum will be computed. And therefore, with that, my dear students and the rest of the learners, we can save all, we close all our files, and we exit from our program. And that marks the end of our presentation on two-dimensional arrays. Remember, you can use the same style and everything to work with three-dimensional arrays and more. The logic remains the same, everything remains the same. You can now proceed to part 23 of 29, listen to it, practice it, watch, and learn on how to pass arrays to functions. Congratulations, therefore, for learning part 22 of 29 on multidimensional arrays in fundamentals of structured programming using C. You can access the rest of the parts in the series, as well as other computer or ICT videos, by clicking or tapping on MLSwap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Thank you very much for listening to me, and let's meet in part 23 of the series, and God bless.